Welcome to AP Chem, Limiting Reactant, another review video. Some visual pictures of what a limiting reactant is. First off, can you write the synthesis of water chemical equation? Remember, synthesis means that it is being made from its elements. So there's your synthesis of water equation. So if I wanted to know what my limiting reactant would be, this chemical equation says that for every 2 moles of hydrogen, I need 1 mole of oxygen. So I'm going to cross off 2 molecules of hydrogen and 1 molecule of oxygen. And I know they're hydrogen because hydrogen's always the smaller one and oxygen's always the bigger one. And it makes 2 molecules of water. Now let's do it again. And again. And again. And again. All right, so we cannot make any more. Who did we run out of first? That's right, we ran out of the hydrogen first. Therefore, hydrogen is our limiting reactant, and the oxygen then is in excess. Again, our limiting reactant was hydrogen because we ran out of it first. And in excess were the 2 oxygen molecules left over. Let's look at a more typical problem. Take a minute and read through this. Now, one of the ways that we know that this is a limiting reactant problem is because it gives us the mass of both reactants. Now, it's asking about the production of ammonia. Again, it's another synthesis reaction. So we need that chemical equation. Remember, to synthesize means to make it from its elements. Yes, you need to know the chemical equation for ammonia. It's NH3, but look, the problem tells you nitrogen gas and hydrogen gas. So there's our chemical equation. The steps. Number 1, you do need to calculate the moles of both reactants. Once you do that, can you ask yourself who the limiting reactant is? Well, you can ask yourself, but you can't tell yet. Next step, and that's to figure out how many moles are needed. Sorry about the little voice thing there. To figure out how many moles are needed, pick either reactant. I don't care which one you choose. I picked nitrogen. You could do this with hydrogen, but I picked nitrogen. And what we're going to do is we're going to multiply those moles of nitrogen by the mole ratio. Where do we get mole ratios? We get them from the balanced chemical equation. This equation says 3 moles of hydrogen for every 1 mole of nitrogen. And that's how many moles of hydrogen I need to make all of the nitrogen go away. So do I have enough hydrogen? Nope, I don't. I only have 0.248 moles of hydrogen, and to get all of the nitrogen to go away, I need more than that. So that means my limiting reactant is nitrogen. I said nitrogen. That was wrong. That means my limiting reactant is hydrogen. I do not have enough hydrogen. Once you've found the limiting reactant, which in this case was the hydrogen, we're ready to calculate how much product. And to go from that, we're going to go from, you can go from the moles or the grams, it doesn't matter, But since we've already calculated the moles of hydrogen, that'll work. So my plan's to go from moles of hydrogen to moles of ammonia and then grams of ammonia. So there's the moles, there's the molar ratio, the molar mass of ammonia, and there's my final answer. Now for a fun question that's often tacked on to an AP, and I know I said fun, but I'm chem geek, right? Anyway, how much nitrogen's left over? Well, we're going to start with our limiting reactant again. Because we know all of the limiting reactant's going to be used up, there won't be any of it left. If the question said how much of each reactant's left over, well, there's none of the limiting reactant left over, 0 grams. So that many moles of hydrogen. I'm going to do a mole ratio between hydrogen and nitrogen, then the molar mass to get to grams of nitrogen, and I end up with 2.32 grams of nitrogen left over, right? No, that's the grams of nitrogen that was used in this reaction. To figure out how much is left over, you need to subtract it from the amount we started with. And that's the amount of nitrogen that's left over at the end of this reaction. Up next, percent yield.